We're at the Nikon booth here at the Quality Expo in Chicago. I'm with Dave Robinson, the CMM Product Marketing Manager for Nikon.
That's right, that's right.
And what are we going to be looking at today?
Today we've got the new ALTERA range of machines from Nikon Metrology and CAMIO software that goes with the range.
And what makes these stand apart from your other models?
Okay, the difference on this model here now is that we have multi-sensor technology as standard on the machine, which gives us the benefit of both technologies that are normally available separately.
And what is that buying for you? I mean, multi-sensor has been around for a while. Have you guys had it in your earlier products?
Now we've truly tied the two together, so it's easy for users to swap between technologies or even upgrade their system as new technologies come along.
When you say it's been built with scanning and so forth in mind, what do you mean by that?
Okay, so traditionally CMMs use a touch trigger probe, which is good for general inspection and can measure most features. Scanning probes, which are tactile, have come along recently, and they give other benefits for getting a lot of data very quickly from the CMM. But they have limitations in terms of productivity when you come to a complex surface. So the laser scanner gives you much more productivity on a complex surface like this.
Because it's faster?
Because it's faster at collecting the data.
Points. Okay, right.
So the three technologies have their own individual benefits, but when you put them together, you extend the scope of the CMM. It's much more flexible.
Well, when you put a scanner on a CMM, are you still constrained by the speed that you would typically use for, let's say, when you're scanning with a touch probe?
No, you get much more data in a much shorter time.
Okay. So what about the motion of the machine itself? Can the machine move faster if you're scanning?
With the machine, normally the machine moves quite quickly in between the measurements with a touch probe, and the measurement is very slowly.
Okay.
Yeah, but with a laser scanner, we're using the almost maximum machine speed all the time.
Okay, so you don't have to slow it down to take data.
You can see here, you could think it's just moving, but it's actually measuring. Okay. Moving and measuring.
All right.
And another benefit on this system, on the new controller technology, is that that's a continuous motion. So again, traditionally CMMs tend to stop, start.
Right.
And that's not so efficient as continually moving, collecting data.
Okay. And you could swap out this scan probe for a regular touch probe.
Exactly. Okay. And the same inspection program could be used. So if a customer starts off with a touch probe, but then they want to get more productivity from the machine or get more data, they can just put on a scanning probe or a laser scanner, and the same inspection program will run, just with a slight modification on some settings. If you move on to the machine one of the aspects of the machine is the material. This material is quite unique within the CMM industry.
Okay.
It's ceramic.
Right.
A lot of competitors use aluminium or aluminum. And aluminum tends to be less stable over time. Right. And these machines go in working environments, so temperature changes and temperature shifts affect the accuracy of the machine.
So ceramic is the preferred material.
So ceramic is a very stable machine, not only in temperature shifts, but over a long period of time. And we guarantee the accuracy of these machines for 10 years. We guarantee that the accuracy of the machine gives on day one will still be there after 10 years. Okay. If not, we will put that right. What you find on an aluminium machine is that it will naturally stress relieve and change over time. The accuracy will change, and at the annual calibration period, the manufacturer will just say, okay, you've got a different accuracy number now, and he'll leave the machine at that. Or he'll charge the customer for the corrective action, which could be a day or two to remap the machine or change components. Okay. So that's a benefit of the structure, if you like.
Okay. And what about software?
Software here is a new product as well. That's CAMIO 8, and that has all of the multi-sensor capability built into CAMIO.
Okay. And what makes it multi-sensor when you say multi-sensor capability?
So the user can easily switch from one sensor technology to the next, and not have the burden of understanding the different techniques of using that technology.
Oh, because in the past you might have had to work with a probe differently than you worked with a scanner, for instance. Okay.
So now all of the intelligence is built into the software, all the controller, all the actual sensor itself. Okay. So it's a really straightforward process for the user.
Okay. Is there something that you can show us with the software?
Okay. So here we are. We can see David's loading in the CAD model of the part, and he wants to inspect that freeform surface to know if there's any deviation in the surfaces. So he's going to use some of the programming tools, selecting to program a series of scans back and forth over the entire surface. Selects the zone that he's interested in measuring. Can add and remove zones.
So the areas in yellow are the areas he's going to measure?
Those are the ones he's interested in. So you can enter some parameters. The software then calculates the probe path.
Now what is this we're looking at now then?
Okay, so you're looking at the entire scan path to measure that entire surface. So the software's looked at what probe or what sensor's being used, it's determined the spacing that's necessary, it's maintaining the optimum position of the scanner so that we collect data all the time during the scan, and it's optimized the scan in terms of maintaining a smooth path through the motion.
And then it'll use a different path depending on whether you're using a touch probe or a scanner, right?
Yeah, different scanner with different parameters, you get a different program.
Okay, all right.
Okay, so the program's now ready. Clicks OK, and then the machine moves off.
And starts
the scanning. Okay. You can see it's all in one continuous motion, which is the most efficient way to collect that data. We're collecting, I'll look it up, but it's about 70,000 points per second.
Okay.
We've got a stripe line there of 60mm stripe, 70,000 points per second.
Okay. And
as those points are being collected, the laser's processing them on the fly so that there's only good data that's returned back to the user.
Right.
And you can see the users, even though we've got different reflectivity on these different surfaces, there's no adjustment for the user. That's all built into the scanner as well. It's adjusting the intensity of the laser on the fly for each one of those 70,000 points.
Okay. That was going to be we're actually scanning a fairly shiny part here.
So you can imagine you've got that line of 1,000 points going along like that. For each one, it's adjusting the intensity.
Okay.
70,000 a second.
Okay. Both the machine and the software, kind of the guiding principle there was just to make life easier for the operator, for the programmer,
and also the time.
To speed it up. Yeah, exactly. Yeah.
So obviously time's critical. Time's money.
Right.
So ease of use and productivity. Okay, so now the scan's complete. All of the data is processed back to CAMIO, and David can now do some analysis with that. So all those thousands of points have been compared to the CAD model. The areas of red and of blue are considered out of tolerance, and if we want to analyse those out of tolerance areas and get some dimensional deviations, we simply click on them and pull out a flyer, and we can see the material condition, high or low.
Right.
Yeah, okay, so.
And that's just basically point and drag then?
Just point and drag. Okay. So instantly you get a yes/no answer with the colour map, and now you can do some further analysis if you need that. So another thing, just for your, customers sometimes slice these components and want to look at the profile around this area because maybe someone's going to mate with it.
Oh, okay, right.
And the odd point here and there doesn't tell them whether it's going to mate.
Right,
it's that profile that's important.
Yeah.
So we just select the axis of that cut. And the result is a profile which we can then view. So we've just turned off the other layers that we were looking at. We're just adding a bit of colour variation into it now.
Oh, that's fine.
So here David's adjusting the colour map so he can configure the colours he wants to warn him when things are out of tolerance, and minimise those colours if it's too much information.
I see.
Yeah?
So now it's showing you're getting colour based on the deviation from the nominal.
Yeah.
Okay. And you're getting your little whiskers there. Okay.
Yep.
All right. Pretty cool. So kind of the upshot of the whole thing is a machine that's been designed, machine and software that's been designed from the ground up to work more efficiently within a multi-sensor environment.
Yeah,
do I have that right?
Not only that, within multiple environments. Sometimes they go in a nice clean room.
Oh, sure. So
another time they'll go in a factory environment.
So that's another point. So this works well on the shop floor as well.
Absolutely, yeah. And that's one of the benefits of the ceramic technology. So it's a very stable material in a range of environments, and we can easily correct for any errors that come from the materials.
Okay. Well, thanks a lot, Dave Robinson of Nikon. All right, and that was it. Thanks. Back to you, Mike.